Hi, my name is Alexey Ilyin. I am an associate professor of physics at the Department of General Physics of MIPT, and today we will discuss solutions of the problems that were offered at the MIPT-International Academic Olympiad in Physics. We will consider solutions of problems contained in problem set PG-01. PG stands for pre-graduation class. There is another problem set, PG-02, which is very similar. The problems and the solutions are very similar to this problem set PG-01. So we will consider and discuss only the solutions to this particular problem set. We start from the first problem, which reads: a nice mass of 1 kilogram is put in an electric heater's tank at a temperature of 0 degrees centigrade. When an electric current of 5 amperes passes through heater's coil made of copper-nickel alloy wire of diameter 1.1 millimeter, the heater melts the ice and warms the water, resulting from ice melting to the temperature of 50 degrees centigrade in time period 20 minutes. The heater efficiency is 60%. First question, find the voltage drop across the heater coil. The solution to the first question is shown below. Q is the total heat required to melt the ice and to warm up the resulting water. Lambda is given to you. This is the heat of ice fusion. M is the mass of the ice, and C is the specific heat of water. So this formula gives you the total heat amount which is needed to melt the ice and to heat the water to increase its temperature by delta T. This is not the total energy spent by the heater, because the heater efficiency is 60%. So the total energy of the heater will be given by this formula, which takes into account the heater efficiency. And the power of the heater will be given by the total energy spent by the heater divided by the time, which is given, which is 20 minutes. And so we obtain the formula which contains only the given quantities, and we may easily calculate according to this formula and obtain the final answer, which is 750 watts. This is the final answer. The second question in this problem is: find the length of the coil's copper-nickel or alloy wire. So we have to find the length of this wire if all the quantities given, like the resistivity of copper-nickel alloy, which is given in this problem, that is the resistivity. And also we have to neglect the heat capacity of the heater's tank and the heat losses to the environment. So in order to find the answer to this question, we use the Joule-Lenz law, which connects the energy released in the heater and the electric current and the heater's resistance and the time period during which this energy was released. The heater's resistance, the resistance of this wire, can be related to the length of this wire, L, and the area of cross-section of this wire, and the resistivity of the material. And so using this formula, we may easily find the relationship between these quantities, and so we find the length of the copper-nickel wire. All the quantities contained in this formula are given in the problem, and so the calculation gives 71 0.3 meters. So the first question in this problem is assessed by 5 points. Each student who obtained correct answer to the first question will receive 5 points, and also the second question is assessed by 5 points if you have found the correct length of the wire. So the total number of points for this problem is 10, as well as for any other problem in this academic Olympiad. Now we continue to the second problem, problem number 9.2. The conductive wire frame shown on the picture is composed of 16 identical pieces of hard wire. A voltage of 9 volts is applied to points A and B. In this case, a current of 0.5 amperes flows through the supply wires. Find the power dissipated by the frame, that is the first question, and the second one, find the ratio of one piece of wire resistance to the resistance between points A and B. The first question can be answered very simply because we have the formula for the power which is released in the wire if released in the resistor if the current I is flowing through the resistor and there is the voltage on this resistor, voltage U. Both quantities are given in this problem, so the answer is easily obtained. It's 4.5 watts. As this question is very simple, only 2 points will be given for correct answer to this question. The second question is much more complicated. You have to find the ratio of one piece of wire resistance, that is like the resistance of this piece of wire, to the resistance between points A and B. Here you see points A and B. In order to solve this problem, we have to note that all this scheme consists of 4 identical elements. So this is the first element, which consists of one wire and another 3 elements connected in parallel to this wire. And the second element with the same view, and then element number 3 and element number 4. 4 identical elements connected together, and let us denote the resistance of one element, say element number 2, between these 2 points. Let us denote this resistance as R prime. In order to calculate this resistance, we have to take into account that this is resistance R, and in parallel to it there are 3 other resistors. And so, using the formula for parallel connection, we have to write that 1 over R prime equals 1 over R, that is this resistance, plus 1 over 3R, the other 3, in parallel to the first one. So this gives 4 over 3R, and therefore R prime equals 3R divided by 4. So we know the resistance of this element, and there are 4 identical elements connected in this circuit. And so to calculate the resistance between points A and B, we have to take an equivalent scheme, which will be like this. The resistance R prime between points A and B, and other 3 identical similar resistances. Each one is R prime. And so in order to calculate the resistance of this circuit between points A and B, we have to use the same logic as before, and the resistance between points A and B will be equal, according to the same logic, 3r prime over 4. So it may be expressed in terms of r. It will be 9r over 16, which is shown here at this solution. I just made a detailed calculation of this result. So the second answer to this problem is somewhat more complicated than the first question, and if you have obtained correct answer to the second question, you will get 8 points for it in this problem. Now we go to the next problem, which is number 9.3. A small ball is thrown vertically upward from the surface of the moon at a certain initial speed, and it reaches a maximum height h, counted from the throwing point, that is, from the surface of the moon. First question, how many times do you need to increase the initial speed so that it reaches a height of 2h? The solution is presented below. We use the law of conservation of energy, because the ball moves without friction, without air drag. There is no air on the moon. And so that the initial kinetic energy will be equal to the final potential energy of the ball when it's on the upper point of its trajectory at the height h from the surface. From this equation, we easily find the initial velocity, and we can note that the velocity is proportional to the square root of h. So if we increase h by a factor of 2, then the velocity also will increase by a factor of 2. That is a simple question, and so if you obtained this correct result, you will get 3 points for this particular question. The second question is somewhat more complicated. It reads, find the ratio of time intervals t1 and t2 through which the ball is at a height of h over 2. In order to find the answer to this question, we have to understand that if this is the surface of the moon and the ball is thrown upward, then it goes upward and then it falls down, and the maximum height of the ball is h, above the surface. And the problem says what will be the time moment when the ball reaches the height h over 2. So when the ball goes up, it will reach this point within the time interval t1, and when the ball goes down, it will reach this point at time interval t2. And we have to find both time intervals, and we have to find the ratio of these two time intervals. In order to solve this problem, we use the equation of the motion of the ball. Y is, in this problem, is the vertical coordinate. And as the ball moves up and down, its vertical coordinate will be a function of time. Which function of time is shown by this well-known equation, which is the equation of the distance covered by a body which is engaged in uniformly accelerated motion. This is a quadratic equation with respect to time, and it's written here in this part that y is actually depends on two moments of time, t1 and t2, if it's equal to to a particular height h over 2. So we use this idea that vertical coordinate is equal to h over 2, and we have to solve this quadratic equation with respect to time. The solution is simple. It's well known to you how to solve quadratic equations. So we find the answer, which is shown here. And we don't have to find the time intervals. We have to find the ratio of these two time intervals. And the ratio is easily found from this formula. When we get minus sign, that will be the minimum time. That will be time t sub 1. And when we get the plus sign here, then we get the maximum time t sub 2. And their relationship is given by this formula. If you obtained this result, then you will be given 7 points for the second question in this problem. Now we go to problem number 9.4. The height of the image of a candle placed at the distance 10 centimeters from a converging lens and located perpendicular to the main optical axis is equal to the height of the candle. Find the optical power of the lens. In order to solve this problem, we have to understand that there is an optical axis in this problem, and the lens is somewhere perpendicular to the optical axis, and there are focal distances of the lens, and there is a candle somewhere. And the image of the candle can be obtained using simple rules. That is the path of one ray, and another ray will go through the center of the lens, and so the image will be here. And that will be the height of the candle, and that will be the height of its image. The problem says that the height of image is the same as the height of the candle. It means that the distance of the candle from the lens equals the distance from of the image from the lens. And that means that the image and the candle itself is located on the double focal distance from the lens, which is indicated here. So this picture just helps you understand why A equals 2 focal distances, double focal distance. So the first question is to find the optical power of the lens. Optical power, by definition, is the reverse of focal distance. And we have just found the focal distance. So the reverse is 1/5 centimeters. But focal distance must be expressed in diopters, which is an international system unit. And we have to use meters in order to calculate optical power in diopters. So we have to convert centimeters into meters, and then we obtain the final answer, 20 diopters. So if you correctly solved this problem, if you found correct answer to this question, then you will receive 3 points. So the second question to this problem is, find the ratio of the height of the image of the candle to the height of the candle if you move the candle at the distance of delta A 20 centimeters from the lens. Actually, the author of this problem meant by this question that the candle was shifted by 20 centimeters. So the new distance is not 20 centimeters. The new distance of the candle from the lens is the previous distance A plus delta A. That will be the new distance of the candle from the lens. So in this question we have to use the formula of thin lens, and we have to take into account that new distance equals a plus delta a. And so from here we can find all the necessary quantities, like b prime, the new distance, and then we can find the ratio of the height of the image to the height of the candle, which can be calculated using this formula, and the final result will be 1/5. If you obtain this result, then you will get for the second part of this problem 7 points. So that the total number of points is again 10 points for the problem, for the 2 questions of this problem. Now we move to the next problem, which will be number 9.5. A puck with a mass of 1 kilogram is pulled along a horizontal surface having the coefficient of friction 0.4 by a spring of stiffness of 50 Newton per meter attached to the puck. And certainly, in order to move this puck, we have to apply some force to the spring in horizontal direction. There are 2 questions to this problem. The first question is, find the elongation of the spring when the puck moves at a constant velocity. If the velocity is constant, then the acceleration is 0, which is indicated here according to the second Newton's law. And in this case, the force acting on the puck from the spring will be equal to the force of friction. 2 equal forces will ensure that the acceleration is 0 and the velocity is constant. So here we have this condition. The force acting on the puck on behalf of the spring, which is the Hooke's law, equals the force of friction. And from here we obtain the elongation of the spring, which is just 8 centimeters. If you obtain this result, you got 4 points for the first part of this problem. The second part of the problem has this question. Find the ratio of elongation of the spring when the magnitude of the puck acceleration is 2 meters per second squared to the elongation when the magnitude of the puck acceleration is 1 meter per second squared. Free fall acceleration must be accepted here as g equal to 10 meters per second squared. In order to solve this problem, we have to use the second law of dynamics, second Newton's law, in case when the acceleration was a1, and also the second Newton's law when the acceleration was a2, in 2 different cases. Different acceleration means different forces acting on the puck. The force of friction is the same, but the force acting from the spring is different because the elongation of the spring is different. So we can find elongation from these equations, and the question is find the ratio of elongations of the spring. So the ratio of elongations is calculated from these 2 formulas and is found to be 6/5. If you found this answer to this question, you will get 6 points. So altogether 4 points for the first part and 6 points for the second part will give you 10 points if both parts of the problem were solved correctly. Now we move to the next problem, which is 10.1. This is the problem for the tense form, and another 5 problems are supposed to be intended for the tense form. The problem says the ratio of the periods of the Earth and Venus rotation around the Sun is 1.6. Find the ratio of the Earth's orbit radius to the Venus's orbit radius. In order to solve this problem, we have to use the Newton's law of universal gravitation, which gives the force of gravitational attraction, which is known as the gravitational constant, and the mass of the central body, like the Sun in this particular case, and the mass of the planet over the distance between the bodies squared. And also we have to remember that this force is the reason for centripetal acceleration of the planet, which is equal to the velocity of the planet squared over the distance to the Sun. And this acceleration, centripetal acceleration times mass, will give you the force according to the second Newton's law. And this force is just the gravity force of the Newton's law of universal gravitation. So from this equation we immediately find the velocity, which is given here. And also we have to use the definition of period. That period is the total length of the circular orbit divided by the velocity. So the period can be calculated as we have found the velocity. The period can be calculated as this formula gives, and we have to find, according to the question of the problem, we have to find the ratio of 2 periods, of the period of rotation of the Earth around the Sun and the period of rotation of Venus around the Sun. So using this formula we obtain this ratio, and actually this is the Kepler's law, and some of you immediately used the Kepler's law. This is correct, this is not a mistake. We have just shown you how to obtain the Kepler's law actually. And the final answer to this question will be 1.4. That is the ratio of the orbit radii. If you obtain this number correctly, then you will get 5 points. The second question, find the orbital velocity of Venus if the Earth's orbital velocity is 29.8 kilometers per second. Again, we use the same formula for the velocity of a planet in its orbital motion around the Sun. You see the same formula, which is used for the Earth here, and the same formula which is used for the Venus. And so we can find the ratio of these two quantities, and it's easily calculated through the known ratio of periods. So the final answer will be 34.9 kilometers per hour for the velocity of Venus in its motion around the Sun. If you obtain this answer, you got 5 points for the second part of this problem. Now we move to the second problem of the tense form problem set, and this is the problem 10.2. A puck of mass m moving along a frictionless horizontal surface with a speed v enters a rough board of length L and mass capital M that is placed on a frictionless horizontal surface as shown in the figure. So this is the frictionless surface, no friction, and also there is no friction here for the puck. But when the puck gets onto the board, here is the friction on this surface. Coefficient of kinetic friction between the board surface and the puck is given, and it's mu. The first question: find the ratio of the initial speed of the puck to its speed after it stops moving relative to the board. If the puck moves along the board and stops relative to the board on it. So the puck moves on the board and stops somewhere on it. And we have to find the ratio of initial and final velocities of the puck. In order to answer this question, we use the law of momentum conservation. We can use this law in this situation because there are no external forces acting on the system of the puck and the board in horizontal direction. In horizontal direction, no forces of friction and no other forces are acting on the system of these bodies. So we can use the law of conservation of momentum. And this law is written here, and directly from this formula we obtain the ratio of velocities, where v small is the final velocity of the board with the puck. If you found correctly the answer to this question, then you got 2 points, because the question is very simple. The next question is more complicated. Find the maximal initial speed that the puck should have to move in order to stay on the board and not fall off from its other end. So we have to find such maximal speed of the puck which allows it to move to the end of the board and stop at this point. If we increase the initial speed, then the puck will go further and will slip off the end of the point of the board. So we have to find such a velocity of the puck which will ensure that the puck goes to the end of the board and stops in this point. To solve this problem, it's possible to use the kinematic considerations based on the second Newton's law, but the solution based on conservation laws seem to be more simple. So we use the law of energy conservation, which in this particular case reads the initial energy of the puck, this is the kinetic energy of the puck, should be equal to the final energy of the puck together with the board plus the work done by the forces of friction. Forces of friction act between the puck and the board when the puck is sliding along the board, along the surface of the board. So forces of friction are acting through all the length of the board, all the length L. We can calculate from this equation forces of friction. By the way, we know which is what forces of friction are equal to. This is the weight of the puck, mg, times the length of the board and the coefficient of friction. And this is the work of the forces of friction, which should be equal to the difference between the initial and final kinetic energies of the puck and the puck together with the board. So from this equation we find the final formula for the maximum velocity of the puck. If the velocity of the puck is greater than this, then the puck will not stop at the final point and will go further and will slip out of the board. So this is the maximum velocity. If you obtained this result in problem number 10.2, you will get £7 points. I'm sorry, the first the first part of this problem is assessed by 3 points, and the second part is assessed by 7 points. Okay, now we go to the next problem, which is problem number 10.3. An ideal monatomic gas in the amount of 2 moles is heated in the process 1,2. So we see the process from point 1 to point 2, which are shown on the pressure volume diagram, where the volume of the gas is directly proportional to its pressure. The work done by the gas in the process 1,2 is given, it's 1 kilojoule, and the gas is heated after this process. The gas is heated in an isobaric process 2,3. So the process 2,3 is isobaric. It means that the pressure is constant during this process. Find the ratio of the heat energy gained by the gas in the process 2,3 to the work that gas has done in the process 2,3. That is the first question in this problem. To solve the problem, we use the expression relating the heat energy required to increase the temperature of the gas by delta T under constant pressure. In order to calculate, according to this formula, we have to remember that the heat capacity under constant pressure equals the heat capacity under constant volume plus universal gas constant. And heat capacity under constant volume equals the number of degrees of freedom over 2. In this particular case, for monatomic gas, the number of degrees of freedom is 3. So here is certainly the gas constant, and we get 3R over 2. And if we add another R, we get 5R over 2. That is exactly what you see here in this formula. So we have expressed the heat given to the gas, which is proportional to R delta T. And using the gas equation, which is known as the pressure of the gas times its volume, equal to the number of moles, universal gas pressure, and temperature. Using this gas equation, we can write R delta T in terms of P delta V, the pressure times change of volume. So this is actually the definition of work done by the gas during the process 2,3. The process 2,3 is the process under constant pressure. So if the gas commits some work, produces some work under constant pressure, then the work done is proportional to the change of volume. And expressing P delta V using the gas equation gives the result R delta T, with nu being a number of moles of the gas. So from these considerations we obtain that the heat amount absorbed by the gas in this process 2,3 is related to the work produced by the gas, and so we get the answer for the ratio of the heat energy and the work as 2.5. If you obtain this result in your work, that correct answer would be assessed by 4 points. The second question in this problem is, find the temperature change of the gas in the process 1, 2. And the temperature change is temperature in point 2 minus temperature in point 1. In order to solve this problem, we have to find the work in the process 1, 2, and the work done by the gas in such a process will be the area under this curve, and this area can be found as P1, the pressure in point 1, plus P2, the pressure in point 2, multiplied by the height, which is V2 minus V1, and divided by 2. This is the area of this figure. So opening the brackets, we obtain this relationship. And it is shown here that because pressure is proportional to volume in the process 1, 2, the pressure and volume can be expressed in this way. So from this relationship between volumes and pressures, we obtain that P1 V2 equals P2 V1. And therefore, these two terms cancel. And what remains in this long formula is just the two terms in the middle, which is indicated here. And then we again use the gas equation to obtain this formula, and which immediately gives the difference in temperatures, which has to be found in the second part of the problem. So calculating this difference in temperatures results in final answer 120.3 kelvins. That is the pressure difference in points 1 and 2. So if you obtained this result correctly, you will get 6 points. Now let's go to the next problem, which is problem number 10.4. Some moist air at the temperature of 100 degrees Celsius is in the cylinder under the piston. Water vapor density is 450 grams per meter cubic. In a slow isothermal process, the volume decreases by 4 times. Find the relative humidity in the cylinder at the beginning of the process. And the second question, find a fraction of the amount of water vapor condensed in the process. So we have to consider water vapor as an ideal gas, and we may neglect the change of the volume due to condensation of water. In order to answer the first question, we have to use the definition of relative humidity. Relative humidity has this definition. It's the ratio of the density of vapor, which is given in this problem, to the density of saturated vapor. In order to find the saturated vapor, we have to use again the law of ideal gas, which is pressure times volume equals universal gas constant times temperature. This is for 1 mole of the gas. If we have arbitrary mass of the gas, we have to use here an expression which will give the number of moles. That is the mass of the gas over the molar mass. Dividing this expression by volume, we obtain the relationship between the pressure and the density. We remember that the density of the gas is mass over volume. So here we will get density over molar mass, universal gas constant, temperature. This expression gives us the relationship between the pressure of the gas and its density. And this relationship is used in this formula, which is intended to calculate the density of saturated water vapor. The saturated steam under normal conditions has pressure of 1 atmosphere. So for the saturated steam, this pressure is 1 atmosphere. It's a well-known fact, and this problem is intended for those students who know that the saturated pressure of water vapor is 1 atmosphere. So 1 atmosphere is substituted here for the pressure of saturated gas, and after calculations we obtain this result, that the density of saturated water pressure is 581 gram per meter squared under 100 degrees Celsius. And the density of water vapor given in this problem is less than the density of saturated vapor. So it means that we may compress the gas slowly, and the water vapor will not start condensation into water immediately. For some period of time, the water vapor or the steam will behave like an ideal gas. And in order to solve this problem, we must understand that condensation takes place at certain conditions, and if conditions are not correct for condensation, then the water vapor behaves just like an ideal gas. The first question is about the relative humidity at the very beginning of the process. So the relative humidity can be found if we know the saturated density, which we have calculated, and so the calculation according to this formula gives the result 77% for relative humidity in the beginning of this process. If you obtained this correct result, you got 4 points for the first part of this problem. And the second part of the problem has this question: find a fraction of the amount of water vapor condensed in the process. So this question requires some clarification. If we draw this process with water vapor on the PV diagram, pressure volume, then we must draw the isothermal process of compression from some initial volume down to lower volumes until the point when the condensation will start. At some point, the condensation of steam will occur, and after that the pressure of the gas will remain constant, because water vapor will start condensing into water, into liquid water. So the process will be isothermal compression until some final volume, and which is known to be the initial volume over 4, according to the condition of this problem. This is indicated again here. And we use the gas law to express the pressure in terms of mass of the gas and its density and temperature and volume. So by using the gas law, we can find the pressure of saturated water vapor and the mass of water vapor, and so taking into account that the volume changed 4 times, diminished by 4 times, we can calculate all the remaining quantities which we need. That is the ratio of the water vapor condensed into water to the initial mass of water vapor, which is expressed by this obvious formula. And what we need is to find the fraction of the amount of water which is condensed. And so using this formula and the gas law and the previous expressions, the final result is found here, which is 0.68. And if you obtain this result in the second part of this problem, you should have gained 6 points for it. Now we will consider the next problem, problem number 10.5, which says a flat capacitor consisting of two vertical parallel plates is connected to a battery with an electromotive force of 50 volts. The distance between the plates is 2 millimeters, and the area of the plates is 0.5 meter squared. Find the magnitude of electric field inside the capacitor. This is the first question. And the first question is very easy to solve because the magnitude of the electric field strength is directly connected to the voltage on the capacitor plates and the distance between the capacitor plates. Both quantities are given in this problem. The voltage is denoted by E. This is not epsilon, this is E, which is given in the problem, which is 50 volts. And so the electric field strength is found to be 25,000 volts per meter. This is a very simple question, and so if you got this correct answer, you obtained 3 points. The second question is a little bit more complicated. Find the charge magnitude change on the capacitor plates when the distance between the plates reduces from D1, which is, you remember, 2 millimeters, to D2, which is 1 millimeter, without disconnecting the capacitor from the battery. So what happens? We have a battery which is connected to the capacitor, and the battery voltage is constant and is denoted by E. And so if we move the plates of the capacitor, then the voltage on the plates will remain the same and will be equal to the electromotive force of the battery. In this case, we have to calculate the charge of the capacitor, which is actually calculated on the basis of the definition of capacitance. The capacitance, by definition, is the charge over potential difference. So, using this formula, we can calculate the charge of the capacitor for the first place when the distance between the plates was D1, and then for the second case when the distance has changed. And if we know the electric charges in these two cases, then we know the difference between these two electric charges, which is directly expressed through the quantities given in this problem. As the quantities are given, we can calculate, we can carry out all the calculations and obtain the final result, which is 10 to the minus 13 degrees Coulomb. This is C is short for Coulomb. If you obtained this answer, then you got 7 points for the second part of this problem. This brings us to the end of the discussion of solutions of the problems that were offered at the PG-International Academic Olympiad. Thank you for your attention.